Hello everyone, we are from Group 3. Here we will explain about similarity.
But we will introduce our team member first. My name Nabila Puspama Dasari. My name is Nafisa Solha.
I'm Daniel Alfonso and me Muhammad Anas.
Now let's start the lesson.
The first topic discussion is history and definition of similarity. History of similarity. Similarity is the idea conveyed by Thales. Thales is a philosopher from Miletus. Thales was just a merchant who traveled alone. Thales tries to explain the world and the phenomena that occur in the world by using human rationale and not relying on the mystic that developed around him. Thales is known as Hoi Hepta Subhoi or the Seven Wise Men. Thales was an expert in geometry, astronomy, and politics. In the field of geometry, Thales found the idea of similarity. Thales at the time could calculate the height of pyramid using only the shadow of a stick. Thales revealed that small triangle formed by the stick and its image is similarity with the triangle formed by the pyramid. By using comparison of the similarity of the two triangles, Thales was able to estimate the height of the pyramid. Definition of similarity. Before we discuss what similarity is, I will give you an overview of similarity. Architects work as someone who designs drawing of building. The picture uses the concept of similarity. The architect uses a scalar comparison, meaning that image and actually building have the same shape but different size. Overview of similarity. Definition of similarity. Two shapes are said to be similarity if each of the two pairs of corresponding points on the two shapes is proportional to the distance of the other two pairs of points. Basically, similarity is two shapes that have the same shape but different size. Similarity can actually be said to be the result of dilatation transformation. Dilatation transformation is a transformation that changes the shape of the geometry shape, whatever it is, reduced or enlarged without changing original shape of the shape. Similarity cannot be at symbol. Similarity has two conditions. First, comparison of the corresponding set lengths. 2. The corresponding angle are the same.
Okay, next I will explain about similarity on various shapes. The first, similarity on square. A square is a quadrilateral with 4 equal sides and 4 right angles. When two squares are similar, their corresponding sides are proportional. This means that the ratio of the length of corresponding side in the two squares remains the same. Understanding the similarity in square helps us analyze and compare geometric figures, particularly when dealing with transformation, measurements, and proportion. By recognizing the proportional relationship between corresponding sides, we can apply this principle to solve various mathematical problems involving square and related shapes. Next, similarity on rectangle. A rectangle is a quadrilateral with 4 right angles. When two rectangles are similar, their corresponding sides are proportional. The ratio of the length of corresponding side remains the same just like in square. When two rectangles are similar, it implies that they have the same shape but their size may differ. For example, if we have two rectangles on a larger and one smaller, their corresponding side will maintain the same ratio. The ratio is often referred to as the scale factor. Next, similarity on triangle. A triangle is a polygon with 3 sides and 3 angles. When two triangles are similar, their corresponding sides are proportional and their corresponding angles are congruent. The ratio of the length of corresponding side remains the same and the corresponding angle have equal measures. Overall, the concept of similarity in triangle encompasses both proportionality of corresponding side and congruence of corresponding angles. This property allows us to establish relationship between different elements of similar triangle, making it a valuable tool in various geometric and mathematical applications.
Now I will explain about the properties of similarity. The first properties of similarity is that the definition of similarity itself. Two shapes are similar if and only if their angles are equal and their corresponding sides are proportional. Because it's the basic of similarity, I think it's very clear and I don't need to explain it anymore. The second properties of similarity is that triangle is the most special shape in similarity. Now maybe you're wondering why triangle is the most special shape in similarity. It's because the first properties that we have here can be simplified and you can see it on the left side. Two triangles are similar if and only if their corresponding angles are equal or their corresponding sides are proportional. We can see that the conjunction and changes to or if we talk about triangle. Now we will prove it mathematically. Look at the right side. We are going to prove it using law of sine, as you can see in the screen. Now if we switch, cross or change the numerator and the denominator, then we will have that the ratio of corresponding side is the same as ratio of sine of angle in front of it, and that means we will have the fact that the angle will be equal, and that proves the second properties of similarity. The last properties of similarity is that if the ratio of corresponding side is k, then the ratio of their area is k squared. Here is the proof of the third properties of similarity. If we have two similar triangle ABC and ABX and CXN, then we can state that AB over ABXN equals to AC over ACXN equals to K, and then we can state AB as K times ABXN and AC as K times ACXN. Now we will look at the area of ABC using law of sine. It's AB times AC times sin angle of BAC over 2, but AB and AC itself can be expressed as K times ABXN and K times ACXN. Then we will have that the area of ABC is actually K squared times ABXN ACXN sine of angle BAC over 2. But this long expression in the fraction is actually the area of ABXN CXN, and that means the ratio of area of triangle ABC and the area of triangle ABXN CXN is K squared, and that proves the third properties.
Topic is example of problems and solution. Look at these two triangles. Are they similar? Sum of interior angles in a triangle is 180 degrees. Therefore, by considering triangle ABC, the sum of angle A, angle B, and angle C equals 180 degrees. So by substituting the given angle measurement, we can find angle C equal 45 degrees. Next, consider triangle DEF. By the same steps, we can determine that the measure of angle D is 36 degrees. Since angle A is equal to angle D and angle C is equal to angle F, hence by angle-angle theorem, triangle ABC is similar to triangle DEF. Okay, look at this image. If the length of AD is 30 centimeters, what is the length of CD? From the given image, we can draw line HB parallel to line AF. Note that HG is equal to FD, which is 5 centimeters, and GB is equal to AD, which is 3 centimeters. Therefore, the length of HB is 5 plus 3 equal 8 centimeters. Since triangle BCG is similar to triangle BEH, the corresponding sides and angles of these triangles are proportional. So we can calculate CG divided by BH equals GB divided by HB. By substituting the known lengths, we have 5 plus x divided by 15 equals 3 divided by 8. So we can cross multiply by 8 and 15 and get 8 multiplied by 5 plus x equals 45. Then 40 plus 8x equals 45. Then we can divide both sides by 8, resulting x equals 5 divided by 8. Since x represents the length of CD, hence the length of CD is 5 divided by 8 centimeters.
That's all from group 3. Hope you enjoy it.
Don't forget to like, comment, subscribe, and see you next time.